A trail camera deep inside a Florida swamp captured footage last year that stopped a room full of scientists completely cold. Not because of what they saw, because of what it meant. A 25-pound bobcat had just killed a 50-pound Burmese python. It had stalked it through the vegetation, identified the precise moment the snake was vulnerable, attacked from exactly the right angle to prevent the python from coiling, targeted the head with surgical precision, and won. A native animal that had been getting eaten alive for 2 decades had just turned around and killed the thing that had been eating it. The biologist who watched that footage, Ian Bartosik, went quiet for a long time before he said a single word. And when he did speak, it was not to celebrate. It was to ask for every nearby trail camera to be checked immediately. Because that footage was not just one strange event, it was the first visible signal that something enormous was shifting inside one of the most broken ecosystems on the planet. And what has happened since then is beyond anything the experts predicted when this whole catastrophe started. To understand where we are right now, you need to understand where this began. The Everglades was never just a swamp. That is the first mistake people make. It was a slow-moving river of grass stretching across the entire southern tip of Florida. A vast subtropical wilderness that filtered drinking water for millions of people, softened hurricane storm surges, recharged underground aquifers, and supported one of the most complex food webs anywhere in the United States. Its ecological value was estimated in the tens of billions of dollars every single year, not because it looked beautiful from the air, though it did, but because of everything it quietly accomplished beneath the surface. Inside that system, life was everywhere. Wading birds moved in enormous flocks over the sawgrass. Alligators ruled the deeper channels. Raccoons, opossums, bobcats, marsh rabbits, foxes, white-tailed deer, otters, and dozens of other species filled the layers of a food web that had been building and refining itself for thousands of years. Every species occupied a role, every role connected to another. The whole thing was ancient, intricate, and perfectly balanced. Then 2 things happened. In August 1992, Hurricane Andrew ripped through South Florida as a Category 5 storm with sustained winds exceeding 165 miles per hour. Near Miami, a reptile breeding facility was destroyed. An unknown number of Burmese pythons escaped into the surrounding wetlands. But Hurricane Andrew was not the whole story. Throughout the 1990s, Burmese pythons had become popular exotic pets across the United States. They were cheap, visually striking, and easy to buy at reptile shows. A baby python fit in the palm of your hand. It looked manageable, exciting, something to show people. But baby pythons do not stay babies. Within a few years, that small snake became a 10-foot, 50-pound predator built to dominate the jungles of Southeast Asia. And when owners realized they could no longer house, feed, or safely handle an animal that outweighed their dog, many made a decision that felt merciful at the time. They drove to the edge of the Everglades and let the snake go. They told themselves they were setting an animal free. What they were actually doing was releasing a biological weapon into an ecosystem that had spent thousands of years building itself around an entirely different set of rules. For years, almost nobody noticed. The pythons moved silently through the grass and water. They blended into mud, vanished under vegetation, and bred in a landscape that seemed specifically designed for them. South Florida gave them everything they needed: heat, humidity, shelter, water, and native prey animals that had never in their entire evolutionary history encountered a predator like this. The native mammals of the Everglades had developed survival strategies over millennia against alligators, panthers, bobcats, and raptors. None of those strategies worked against a 20-foot constrictor that hunted by pure ambush, detected body heat, in total darkness through pit organs along its jaw, and could hold its breath underwater for extended periods. A raccoon moving along a canal bank at night would never know the snake was there. The first sign would be the coils closing around its ribcage. And then there was the breeding. One female can lay up to 100 eggs in a single clutch. She coils around the nest for the full incubation period, shivering her muscles to generate metabolic heat, defending the eggs against anything that approaches. With no natural predators, unlimited prey, and perfect habitat stretching across millions of acres, the numbers climbed fast. Current estimates suggest somewhere between 100,000 and 300,000 Burmese pythons are now spread across South Florida. Then the data arrived. Not anecdotal reports, rigorous multi-year survey data collected by teams of wildlife biologists working systematic transects across the Everglades, comparing population counts from before and after the invasion reached critical mass. In the hardest hit areas, raccoon numbers had crashed by more than 99%. Not a gradual decline. A collapse so total that survey teams covering miles of prime raccoon habitat came back with 0 detections. Opossums were down almost as far. Bobcats had dropped dramatically in areas where they had once been the dominant mid-level predator. Marsh rabbits and foxes were functionally gone in some survey zones. Not reduced, not struggling, erased. The animals that had occupied these habitats for thousands of years had been consumed faster than they could reproduce. Biologists who had spent entire careers in the Everglades described something they struggled to put into words for people who hadn't experienced it. The feeling of walking through habitat that should be alive and finding it completely empty. Miles of prime wildlife corridor where animals once crossed roads and moved through brush now sat motionless. No rustling in the sawgrass, no movement at the water's edge. No small mammals appearing during nighttime surveys that had once produced dozens of sightings per hour. The swamp was still alive in the strictest biological sense, but something essential had been eaten out of the middle of it. Florida's first major public response looked almost like spectacle. The Python Challenge, an open call for hunters to enter the swamp, remove invasive snakes, win cash prizes, and generate headlines that gave people the feeling that something was being done. But the math was brutal. In 2024, the total haul across the entire challenge event was 195 pythons. Removing a few hundred snakes from a population that may number in the hundreds of thousands is like trying to empty the Pacific Ocean with a paper cup. The effort was real. The dedication was genuine. The result was statistically invisible. The Professional Python Elimination Program, which has been running since 2017, had removed more than 27,000 pythons from the wild by the time of the 2026 Python Challenge. That sounds enormous. It represents thousands of hours of hunting through chest-deep water in 100-degree heat, scanning vegetation for an animal that is essentially invisible against its background, and physically capturing snakes that can exceed 15 feet and 100 pounds. But 27,000 may still represent only a small fraction of the total population, a fraction the remaining animals can replace through breeding within a single reproductive season. A single female python laying 80 eggs in one clutch can offset the work of an entire hunting team across an entire year. The problem was not effort, it was the animal. Thermal drones failed because pythons are cold-blooded. They produce almost no heat signature, and the Everglades itself is hot. The background temperature of the swamp swallowed whatever faint thermal difference the snakes produced. Mechanical decoys failed because ambush predators do not chase fake prey on command. They sit motionless for days, waiting for real prey to walk past. And then field teams began noticing something that made the whole problem significantly more unsettling. The pythons seemed to be changing their behavior. Traps that worked one season stopped working the next. Productive hunting areas suddenly went quiet, not because the snakes were gone, but because they had moved deeper into terrain that no removal crew could effectively operate in. Backcountry habitats so flooded, so remote, so dense that the animals were functionally beyond reach. And the documentation suggested this was not random. The careless snakes were being removed. The wary ones survived. The wary ones bred. An apex predator that was already nearly impossible to find was potentially becoming better at disappearing with every single generation. Florida had thrown hunters, drones, traps, and tracking programs at the invasion, and the invasion appeared to be adapting. And then came something nobody was watching for. While researchers focused on python numbers, another invader was spreading through Florida almost silently. Scientists call it the snake lungworm, a parasitic worm native to Southeast Asia. Burmese pythons carry it because they have had thousands of years of coevolution to tolerate its presence. The parasite lives inside them without causing significant harm, the way many host species carry parasites that their immune systems have learned to manage across deep evolutionary time. But Florida's native snakes had no such history. No coevolution, no tolerance, no defense. Researchers examining native garter snakes and pygmy rattlesnakes found animals that were thin, lethargic, moving slowly, struggling to breathe. When they opened them for examination, they found the cause. Their lungs were filled with tiny parasitic worms. Dozens of them burrowed into tissue, blocking airways, feeding on blood, spreading through animals that had never evolved to carry them. The transmission chain is disturbing in its efficiency. An infected python deposits waste in swamp water, releasing microscopic lungworm eggs into the environment. Cockroaches, which are present in enormous numbers across the Florida wetlands, consume that waste and pick up larval parasites. Frogs, which feed on cockroaches, ingest the infected insects. Native snakes, which feed on frogs as part of their normal diet, consume the infected amphibians. Each step in the chain is a completely routine feeding event. No unusual behavior required. No special conditions needed. The parasite simply rides the existing food web from host to host, moving through the same predator-prey relationships that have existed in these wetlands for thousands of years. Inside the native snake, the larvae tunnel through the stomach wall, migrate through the body cavity, and embed themselves into the delicate membrane of the lungs where gas exchange occurs. They feed on blood. They multiply. They fill the lung cavity with their bodies and their offspring, until the animal can no longer breathe. Researchers have found cases so severe that lungworms were crawling from snakes' mouths as the animals died. And then came the darker discovery. The parasite had already spread beyond the Everglades. At least 18 native snake species were infected across a geographic range far larger than anyone had anticipated. And worst of all, it no longer needed Burmese pythons to keep spreading. It had jumped into native transmission cycles. Cockroach to frog to snake, without any contact with a python required. Even if every Burmese python in Florida disappeared tomorrow, the parasite would remain. Self-sustaining. Permanent. A biological legacy of the invasion that would continue damaging native wildlife long after the invaders themselves were gone. The Everglades was being attacked from two directions simultaneously. From above, pythons were consuming the mammals that formed the middle of the food web. From within, lungworms were destroying the native reptiles that held the lower tiers together. The ecosystem was being hollowed out from both ends at once. But in the middle of that disaster, researchers found one result that did not fit. The Florida cottonmouth kept coming back clean. This venomous pit viper, living in the same infected habitats, sharing the same prey base, showing up in the same survey zones as all the other infected native species, had no signs of lungworm infection across multiple sampling periods. No worms, no respiratory distress, no symptoms of any kind. Something in the cottonmouth's biology was blocking the parasite. Nobody yet knows the precise mechanism, maybe an immune response that neutralizes the larvae before they can migrate. Maybe something in the blood chemistry that makes the lung tissue inhospitable to the worm. Maybe the venom itself plays a role. The mechanism remains unidentified. But the implication is enormous. If one native snake has somehow developed resistance, that resistance might eventually become the key to protecting others. Scientists marked it as one of the most urgent, unanswered questions in Florida wildlife biology. And then, Florida announced the plan that sounded insane to almost everyone who heard it. They were going to release more snakes. When word spread that wildlife officials were deliberately putting more snakes into the Everglades, the reaction was immediate. Wasn't the entire problem too many snakes? The critics compared it to the cane toad disaster in Australia, a human solution that became its own catastrophe. But this was fundamentally different. The snake being released was not another invader. It was a native predator returning to a kingdom it had lost. The eastern indigo snake, the longest native snake in North America, a shining blue-black animal that can reach up to 9 feet in length, its scales carrying an iridescent sheen that shifts between deep indigo and purple in direct sunlight. It is unmistakable. It is beautiful. And it behaves like the undisputed apex predator of the forest floor. The indigo is an ophiophage, a snake eater by evolutionary design, and it is completely immune to the venom of every North American pit viper, rattlesnakes, cottonmouths, copperheads. It eats them without consequence, without hesitation, without showing any physiological response to venom that would kill a human in hours. For a long time, nothing on the forest floor could challenge it. The eastern indigo did not vanish because another predator defeated it. It vanished because its habitat disappeared. As development destroyed longleaf pine forests across northern and central Florida, gopher tortoise populations declined. And when the tortoises disappeared, the indigos disappeared with them. By the late 1970s, eastern indigo snakes were federally listed as a threatened species. Their range had contracted to isolated pockets in southern Georgia and the Florida peninsula. An animal that had once ranged across the entire southeastern coastal plain had been reduced to scattered remnant populations. For decades, conservation groups worked quietly to reverse the collapse. They bred indigos in captivity. They restored longleaf pine habitat. They reintroduced gopher tortoises into protected areas. The program that began releasing snakes at the Apalachicola Bluffs and Ravines Preserve in 2017 has now completed its 10th consecutive annual release. In late April and early May 2026, conservation teams released a total of 42 juvenile eastern indigo snakes into protected habitat, and field monitoring has confirmed the presence of wild-born hatchlings, a female snake originally released in 2019 still alive and active, and a 6-foot-long male establishing territory on his own terms. Over 500 snakes have now been released across Florida and Alabama combined. The king is not just surviving. It is reproducing. It is rebuilding a wild population entirely on its own terms. And while that was happening in the north, something unexpected was unfolding in the south. A trail camera inside Big Cypress National Preserve captured a bobcat weighing roughly 25 pounds, killing a Burmese python that weighed approximately 50 pounds. The bobcat had not blundered into the snake. It had hunted it. It had stalked it through the vegetation, identified a moment of vulnerability when the snake was exposed, and not in a defensive coil. Attacked from the precise angle that prevented the python from establishing a coil, targeted the head directly, and won. The python never had the opportunity to deploy its primary weapon, because the bobcat never gave it one. Researchers confirmed that a bobcat had predated upon one of their tracked scout snakes, and separately, an endangered eastern indigo snake was documented consuming a tracked hatchling python, events that biologists described as wins for the home team, visible evidence of the Everglades fighting back. Reports from across South Florida had begun showing other native predators interacting with pythons in ways that had never been documented before. Alligators ambushing smaller snakes at water crossings. A Florida panther filmed taking down a mid-sized python in the sawgrass. Native predators identifying the moments when even a perfect ambush predator is most vulnerable. After a large meal when its body is distended and its reflexes are slowed. During water crossings when it is exposed and unable to anchor its coils. During the brief gaps when an apex predator is not fully ready. This does not mean the pythons are losing. They are still winning by numbers, and they will continue winning by numbers for a long time. One bobcat killing one python cannot undo 20 years of ecological collapse, but the dynamic has shifted. It is no longer pure slaughter in one direction. For the first time, what is happening in the Everglades looks less like an extinction event and more like an arms race. And the human effort has taken a step forward that is genuinely remarkable. Between November 2025 and April 2026, the Conservancy of Southwest Florida removed 177 pythons from a 200 square mile area in Collier County, weighing a combined 8,080 pounds, the first 4-ton removal season in the program's history. The method that made it possible is called the Scout Snake Program. Researchers take male pythons, implant radio transmitters, and release them back into the wild during breeding season. Those males, now known individually by names like Snoquan, Lincoln, Vladdy, and Fenrir, lead the tracking teams directly to mating aggregations, deep in terrain that hunters could never reach on their own. The average female captured this season weighed 95 pounds, carried approximately 70 eggs, and a quarter of them already contained the remains of white-tailed deer. The largest female measured 17 feet and weighed 153 pounds. The team blocked an estimated 4,100 python eggs from entering the wild in a single season. That number, 4,100 eggs, is what matters. Not the snake count, not the pounds. Every egg prevented is a python that will never hunt, never reproduce, never eat a bobcat or a deer or a marsh rabbit. The Scout Snake Program is not eliminating the invasion. It is suppressing reproduction in a targeted zone. And if the suppression holds and expands, the native wildlife in that zone has a chance to begin recovering. A chance that did not exist 5 years ago. Now here is where everything is heading and why it matters more than almost any wildlife story in North America right now. The eastern indigo population is spreading. Wild-born snakes are expanding from restored habitat in North Florida, establishing new territories, finding mates, producing offspring without human assistance. At the same time, Burmese pythons have been pushing north, following waterways, following warming temperatures, following habitat corridors that connect the Everglades to central and eventually northern Florida. A Tufts University study found that climate change could make the entire continental United States hospitable to Burmese pythons by 2050. The two populations are moving toward each other. No one knows exactly when they meet, but the geography makes it inevitable. An eastern indigo, fast, aggressive, immune to venom, evolved over millions of years, specifically to hunt and consume other snakes, facing a Burmese python that may outweigh it by 40 pounds or more. The indigo's strategy has never been size. It is speed, jaw strength, relentless pressure, and an absolute refusal to release once it has locked on. It has taken eastern diamondback rattlesnakes. It has taken cottonmouths without hesitation. It has consumed other indigo snakes in territorial disputes. But it has never met anything like a full-grown Burmese python. No one has documented that encounter. No one knows whether the strategy that works against every native snake the indigo has ever faced translates against a constrictor that may be 3 times its weight. And then comes the darker possibility. The lungworm is also moving north. If the eastern indigo expands into infected territory before scientists understand whether it carries any resistance, it could walk straight into a biological trap. The parasite that has already crossed into at least 18 native snake species could reach the very animal that conservationists have spent nearly a decade trying to restore. Half a century of captive breeding, habitat restoration, and careful reintroduction work could collide with a microscopic parasite that no one yet knows how to stop. That is the real situation the cameras revealed. Not victory, not collapse. Something stranger and harder to predict than either. A damaged ecosystem searching for a new balance between an invasive giant, a microscopic parasite spreading silently through the food web, a native apex predator returning from near extinction, and local animals that are finally, after 20 years of silence, beginning to fight back. The bobcats are learning. The indigo is reproducing. The cottonmouth may be carrying a clue inside its blood that nobody thought to study until now. And the swamp, after 2 decades of being consumed in silence, is no longer passive. But nobody knows who wins. Does the eastern indigo arrive in time? Can it challenge the python on its own ground? Does the lungworm reach it first? Does the cottonmouth's resistance unlock an answer that scientists can apply to other species before the damage goes too deep? Do bobcats, panthers, and alligators learn fast enough to matter before the mammals they depend on are completely gone? No one has those answers yet. And that is what makes this moment extraordinary. For the first time in 2 decades of slow, seemingly irreversible ecological collapse, the ending of this story is no longer certain. The trajectory is no longer a straight line pointing toward total loss. Something has changed in the Florida swamp. Multiple things have changed, and they are all converging at the same time in the same wounded landscape. The Everglades is still wounded. The invasion is still real. The parasite is still spreading. The mammals are still depleted. The food web is still fractured. But the swamp has started moving again. A bobcat that weighs 25 pounds is learning how to kill a snake that weighs twice as much. An indigo snake born in captivity in central Florida is now producing wild offspring in North Florida for the first time in 50 years. Scientists are removing 4 tons of pythons per season, using the snake's own biology against them. And inside the blood of a venomous pit viper that nobody thought to study until now, there may be a chemical answer to a parasite that is otherwise unstoppable. The next chapter of this story will be the most unpredictable one yet, because it will determine whether an ecosystem that took thousands of years to build can find its way back from the edge, or whether the damage is already too deep, the invaders too entrenched, and the window of time too short for any of it to matter. What started as a disaster caused by people releasing pet snakes into a swamp has become one of the most complex ecological battles in American history. And right now, for the first time in a very long time, it is not entirely clear that the invaders are going to win.